All right, guys. Thank you for listening. I'm sorry, I'm the only talk holding you guys between that and break. But yeah, like I said, I'm going to be talking about Diorhabda's impact on Tamarisk in the Middle Rio Grande. Just a little bit of background. Salt cedar or tamarisk, which I'll probably use interchangeably, I apologize, was introduced in the 1800s as a method of erosion control. And it was favored for eradication because it has a high intensity of water usage. It can act as a ladder fuel to the sensitive cottonwood canopy. And so it's been favored for eradication, but has been proven really difficult through conventional methods, such as cutting or spraying. So in 2008, the tamarisk leaf beetle, or Diorhabda, was introduced as a method of biological control. And there was concern for this migration into New Mexico at the expense of the southwestern willow flycatcher. This is just a little bit of background of the history of Diorhabda's spread over time. So it was introduced in 2008, and that's represented in the red and the yellow circles. And then it proliferated into more areas of the Southwest, as seen in the light blue and the purple. And these are a lot of our data points. And our data points refers to BEMP. So I know that Kim Eichhorst gave a lightning talk about BEMP earlier, but stands for the Bosque Ecosystem Monitoring Program. And it focuses on the long-term ecological research of the Middle Rio Grande Bosque. And we're a community science-based organization in collaboration with UNM and Bosque School. We focus on science, education, and stewardship of the Middle Rio Grande. And we've been fortunate enough to reach 100,000 people in the last 23 years, starting in 1996. And now we have 33 active research sites. And in monitoring these sites, we hope that our research will inform land managers to make educated decisions based on the ecological health of the Rio Grande Bosque. Here is a map of the stretch of our sites, all of our 33. And the next few slides, I'll be talking about our stretches and reaches of where we find the tamarisk leaf beetle. So I talk about north of Albuquerque, and those are our Pueblo sites. All of our Albuquerque sites, they're blown up on the right here. And then all of our south of Albuquerque sites, anything south of Albuquerque, mostly in Valencia County and Belen. And I have a heavy emphasis on our Crawford site, which is our most southern Belen site right here. This is an example of one of our sites. For the most part, they all look like this. They are 200 by 100 meters with 10 vegetation, 10 vegetation transects with litter fall tubs represented by the circles. And the sites that are monitored for tamarisk have 5 trees that are represented by the red numbers that are about 5 meters apart from each other. So when we monitor for the tamarisk leaf beetle, in the field, we have 5 trees, 5 meters apart, and using an insect net, we swipe the trees 5 times, collect what's inside, freeze them, and then process them later at UNM. In the field, we're looking at relative defoliation, both brown and yellow. We also look at the relative percent of dead canopy, and we started doing that in 2017. We also take a photo of each tree from a fairly similar vantage point. And then once that's done in the lab, we're looking at other tamarisk specialists as well. So looking at things like the weevil, the leafhopper, and various larval stages of the tamarisk leaf beetle. Oops. So in doing this, what we found over time is this increase and decline of the beetle. And you can see that overall, these are tamarisk leaf beetle adults and the years of continuous monitoring. And we see this overall increase followed by a decline and increase and decline. And if you look at the southern Albuquerque sites in the purple, you can see we were lucky enough to catch the emergence of the beetle. And so you see this increase in tamarisk leaf beetle followed by a decline and then a recovery period. And we hypothesize that this is going to be more or less what we see as we continue monitoring, but abundance of tamarisk leaf beetle adults is really variable throughout time. So from the beetles, this is the trend of defoliation that we see across our sites. This is from the Crawford site. You can see this is the same tree monitored throughout the season in May. It's relatively foliated, June, July, and then in August you can see this huge impact of the beetle of defoliation over time. And this is consistent across most of our sites throughout the season. So you see this linear trend of model defoliation by month and relative percent of defoliation increasing throughout the season. And this is relatively consistent throughout all the sites we see. And so after years and years of these defoliation events, we've observed changes in the density of our canopy of selected trees at each of our sites. This is that same tree at the Crawford site that I showed in the earlier slide. And just looking visually at the tree, you can see how dense it is. You can't see the jetty jacks through these photos, even though the vantage point differs, probably because of flooding. But if you skip to 2019, you can just see visually the impact that the beetles had through these defoliation events across time, losing a lot of the canopy density. We've seen this photographically, and we also see this numerically in the data that we've collected of relative percent canopy over time. So in addition to losses of density of canopy over these prolonged defoliation events, we see the evidence of beetle changing the phenology of tamarisk in our litterfall data. So this is our Crawford site again, looking at 2011 through 2014. You see a trend in salt cedar litterfall drop, as you would with any kind of deciduous tree for the most part, with spikes in increase in litterfall drop in the fall months. And this is in grams per meter squared across time. But when we start to see the emergence of the beetle, starting in 2015, you're starting to see these increases in leaf litter drop in the summer months, as you can see in 2016, as it was experienced in 2017, and a variation of that in 2018. So what we're seeing is that after high periods of beetle abundance, we're seeing a change in the shift of timing of salt cedar leaf litter fall. So just to conclude, the defoliation is predicted to continue annually. I don't really think the beetle is going anywhere at this point. The changing of timing of salt cedar drop is likely because of the beetle. The trees are losing their canopy density, so this is directly impacting the understory, either for the flycatcher or potentially anything that lives even below the understory. The beetle abundance and population are variable, and we're unsure if this is an effect of flooding or temperature or resource availability, but that could be something that BEMP could look into in the future. And with that, I'll take any questions.
Thank you. Are you seeing anywhere where it's actually killing salt cedar? It looks like it just defoliates and then it comes back every year.
Yeah, we've only seen one event of mortality at one tree at one site, and it's, yeah. And that occurred at the Santo Domingo Pueblo. And I don't think it was because of any other stressors at the site. There's really no evidence of other events of mortality of the surrounding vegetation. So it could be from the beetle, but that's the only monitor tree we've seen die.
Other questions?
How can you tell the difference between damage done by the leaf hopper and the leaf beetle?
I believe that the leaf hopper is yellow defoliation and the beetle is brown defoliation. So that's why we record the difference between the two. But in the slides that I just showed you, it was just defoliation in total.
Are you able to monitor and see if any of these surrounding species are increasing in response to the tamarisk canopy getting thinner, or can you see a response in herbaceous understory? I'm just thinking that plants compete, so as you have less salt cedar, you theoretically should have something else coming in.
Yes, I would love to look at that. And we do have the option, we have long-term vegetation data as well as, and the litter fall goes back all the way to 1997 in some parts, so we could compare long-term vegetation coverage as well as litter fall, but that's not something I've looked into yet, but want to, so thank you. Okay, yeah,
Thank you, everybody.